Sorry I'm not in class today, but hopefully this online lesson will be helpful and be almost the same as if you were there in class. If you have any questions, please look them up yourself, talk to your table group, or email me or call me or come see me in office hours and I'd be happy to help. This lesson is going to be on operations. A mathematical operation is an action that operates on one or two numbers at a time and results in the same number or another number. So take a minute right now, sit down, take a piece of paper, and jot down as many mathematical operations as you can. You might start looking on your calculator pad, and you may use notation to indicate the operations that you list. Take a minute and do this now. If we were in class, I'd actually ask you to each to share the operations that you wrote down. But since we're not, here's a sample of things you might have on your paper. Some of these might look familiar, some may be unfamiliar to you. But this is an example of what I've seen in classes before when we compile the list of operations from the class. How many of these did you write down? Well, there are some operations on this page, and there's some that aren't operations. The three columns on the left are operations. Each of them acts on one or more numbers and turns it into the same number or another number. The ones in the right column are not operations. Sometimes we think of parentheses, and it could mean multiplication, and that is an operation, but just putting parentheses around something doesn't take an action on them. If I put a number like 17 inside the parentheses aren't going to do anything to 17 or turn it into another number. The percent sign doesn't act on a number. If we're talking about 93% score on our quiz, the percent sign doesn't do anything to our 93. It just lets us know that you had a score of 93 out of 100, but it doesn't act on the number 93. The greater than sign or the less than sign or greater than or equal or less than or equal signs, they don't operate either. They simply show a relationship between two numbers. When we say 4 is larger than 2, we don't act on the 4 and 2 and change them into another number. We're just stating the relationship between them. The equal sign isn't an operation either. It's simply a notation that says the stuff on the left side is in the same amount exactly as the stuff on the right side. Often when we use an equal sign, we're using it in an equation that has an operation, like 4 plus 2 equals 6. But it's the plus sign that's doing the operating, not the equal sign. Binary operations are a special kind of operation. Now, some of our mathematical operations act on one number at a time, like absolute value. For example, the absolute value of negative 2 is 2. The absolute value bars do operate on the negative. It strips it of the negative sign and just reports the magnitude or the absolute value as being positive 2. But the binary operations act on two numbers at a time and produce one number, somehow combining them. I love this cartoon in Calvin and Hobbes. Our family loves Calvin and Hobbes. In the second frame, he's talking about binary operations. They magically become one new number. We will be studying 4 binary operations in this class. These are the ones that are taught in the elementary grade levels. So now, circle or highlight on your list of operations, or the list you may have seen earlier, which are the 4 simple binary operations that we're going to study. And for those of you with a curious mind, which of the other operations on that list are also binary operations, but we're not going to spend a lot of time studying them? Stop and jot down any questions you have at this point. Keep your questions till the end, and then you can look for answers. Did you write down addition, subtraction, multiplication, and division? These simple binary operations work on 2 numbers at a time and combine them into one number. Sometimes we might add 4 numbers together, like 6 plus 7 plus 14 plus 10. But the binary operation has to be listed in between each of those pairs of numbers. We don't have one addition sign and it tells us to add all four. We have to have an addition sign between each pair of numbers. Now, if we're mixing up operations, for example, 12 divided by 4, subtract 2 times 6, then we must use the order of operations to get the correct answer. We'll talk more about order of operations in a future lesson. There are also inverse operations. Many of our mathematical operations have inverse operations, which are opposite of each other, or undo each other, or cancel out each other's actions. Go back to the list. What are the inverse operations for each of our 4 binary operations? What are some of the other binary operations? Actually, what are some of the other operations that have inverses? For example, cosine and all the other trig functions, they also have inverses. If you were in trigonometry class or pre-calculus, you might remember that the inverse of cosine, see, it uses the word inverse for the inverse operation. Inverse cosine is the opposite of taking the cosine. Those two operations undo each other, or are opposite or cancel each other's operation. So remember in algebra class when you were solving for x, such as 3x minus 15? I think if we were in class and I asked you how to do it, you'd all say, add 15 to both sides. Why are you adding 15? It's being subtracted in that equation. You're adding 15 because it undoes the subtraction of 15. Then when we put the 15, we get 3x equals 15. Then what do? We divide by 3. Why divide? Because we're undoing the multiplication of 3 to the x. When we solve this using 2 inverse operations, we find out that x equals 5. This lesson introduced the idea of operation, binary operation, and inverse operation. Make sure you understand each of these things. If you're unsure of anything in this lesson, either research it yourself, get your Google thing out, discuss it with members of your table, or email or call the teacher. See you next class. Be happy.